Hi everyone, this is a short recording to support this presentation that was originally made by Pip, Lily and Amelie in year 10. I've just adjusted the layout a little bit and added a couple of links, but otherwise it's all their own work. Okay, so the life cycle, you'll see many different variations on this, but the main parts are analysis, which means looking at the problem that you want to solve, then designing a solution to the problem, implementing it, and testing it. And then once you've done that, you can evaluate and go back to the beginning. Planning, obviously, is a stage. It's often included in analysis. Okay. So, and I will focus on the bits that come up most often in the paper. Okay, so before you can actually start analyzing the problem, you need, in your planning stage, is to collect as much information as you can about the current system. Okay, and I've put a link on here which goes to a website which tells you about the different ways of collecting information. This comes up a lot, okay? So you need to know the advantages and disadvantages of different ways of collecting information from people about the system. So you can do this by observing them, by interviewing them, by doing questionnaires, and by collecting documents that already exist, okay? So make sure you know those and which ones you would apply. For instance, if people were working 24/7 online, then getting time to interview them might not be a great idea. But an online questionnaire might be, okay? So that's the kind of thing you want to look at. Okay, so once you've collected all your data, you have to analyze it, okay? Which means looking at the problem that you have and how are you going to solve it. Okay, and on here they've given you an excellent example of a payroll system. Okay, so and with every system you have information that goes in, your inputs, the actual system that will work on the information that you've put in, and then your outputs. So here you've got timesheets, pay rates, bank account details that all goes into the system, and then you get outputs like pay slips, payments, and salary reports. Okay. They don't really ask you very often to identify what you think would be the problems with a particular system, but they might. So they might say so-and-so has a payroll system or a system for taking stock, and ask you to come up with some ideas about what might be the problems. But as I said, they don't very often ask about that. Again, new system requirements come out of your analysis. So by doing your analysis, studying the problem, then you come up with a requirement specification. So for instance, if it was a school database, they might ask all the teachers, what do you want it to do? And they say, well, the current system doesn't allow us to move students easily from one class to another. So that will be the system requirement that they'll say, right, well, the new system will need to do that. Okay. And there we go, a lovely bird animation flying off into the distance. Right, hardware and software requirements. Again, you need to know this, but they don't very often ask you to recommend what hardware and what software, but they might. And so generally it's common sense, okay? So from your other knowledge about computers and RAM and ROM and what speed they run at, for instance, if you had a company that was editing videos, they would want really high-spec computers, okay? What type of network would they want to run on? Again, these questions don't come up a lot, but I wouldn't focus too much on that. Design. Come up with a new system that will fix the present system's problems. So that's the next stage. Now, this comes up, okay? They very often ask what kind of things would need to be designed. And if you just learn these, okay, don't matter if you don't know what file structures are or production of algorithms and flowcharts, there's very often a question about what kinds of things would you need to look at in the design section, okay? You also have to design how you are going to get information into the system, okay? So there's manual data input. You can have data input through keyboards or scanning into a computer. And I've put a link on here that tells you that information about the different ways of getting data into a system, okay? Most these days, this is probably the most common way of doing it, okay? On here, data validation techniques, you need to know these. Now, this is just the ways that you will build into your system of checking that the data that is being input is reasonable. It doesn't check to see if the data is correct. So what that means is, for instance, if I had a system that was ordering loaves of bread, I could put a validation check in, say a range check. Here you see it here. Okay, so I might say we only want people to order bread between 1 loaf and 10 loaves of bread. Now, if they were to put in more than 10, that's out of the range, so it would come up with a thing saying, it's not in the correct range, please try again. Or if you would like to place a larger order, call this number. Now, if someone puts in 7, the range check will say, that's a reasonable amount of loaves of bread to offer. It doesn't mean it's correct because they might have actually wanted to order 6 or 8. So they very often put in a question saying about, do validation checks make sure the data is correct? No, they don't. They make sure that the data is reasonable. Okay, you need to learn these different types of checks. Okay, length check, type check, and so on, in case you get a question on it. Right, testing the new system and documentation. Okay, you need to know the types of tests that could be carried out. Again, I've put a link here because it wasn't in the original presentation. Okay, so these are data tests, and we've spoken about this, about the 3 different types of data that you can use: normal, extreme, and abnormal. Now, people often get these mixed up, okay, because extreme data is the data that is at each end. So if you've got a range between 1 and 10, the extreme data is 1 and 10. Normal data is 2 to 9, and abnormal data would be 13 or -1. Okay. Again, that is a question that comes up quite often, and that is usually what they ask about, what are you going to test? Okay. And this comes up 9 times out of 10. So please learn this. It's only 1 page on this link, and it's the different types of documentation that have to be produced to support a system. Now, they're divided into 2 types: user information and technical information. Okay. Now, user documentation, you should know this from any new software you've bought, or when you bought your PS5 or whatever. Okay, how to install, quick setup guide, screenshots, what are the inputs and outputs, what do the error messages mean, troubleshooting guide. Where people fall down is on the technical documentation. And all I can suggest, as I did before with the other one, is that you learn these. Okay, so if they ask about technical documentation, things like hardware and software data structures, expected outputs, validation checks, okay, again, just learn these. These ones you'll probably recall off the top of your head. Okay. And then you have the implementation section. Again, there's one part of the implementation section that nearly always, if you're going to get a question on design lifecycle, they like to ask this. And that is the different ways of implementing a system. Now, the girls had put these all on one slide. All I've done is split them onto 3 separate slides. So you can see there's direct changeover. So you go straight from the old system into the new system. Okay, you need to know the advantages and disadvantages. Parallel running. So as you can see from the diagram, you've got the old system running and then you start the new system. So both systems are running at the same time. Now, obviously, this is not a very effective way because you're double inputting all the data, but it is a careful way of doing it. So you pick up on any problems with the new system and you've still got your old system running. Okay. And then there's pilot running, which in my eyes is one of the best ways to run a system, but it's not always possible because if you've only got one branch of a company, there isn't any way you can run a pilot unless you only run it with a few people. Okay, it's nice to run a pilot at a separate branch of a store, for instance. So you have the old system running, and that continues to run while you run your pilot system, and then both of those will stop, and then you introduce your new system after ironing out all the problems with the pilot system. And here endeth the presentation. So I've just gone through it really quickly. I want you to go through it in depth, and remember, year 10, this is something you're going to have to learn. It won't necessarily be in your mock. Year 11, there are chances that these questions are going to come up in your exam. Thank you very much. And I need to find stop recording. Look at that, the design life cycle in 12 minutes and 57 seconds.